Okay, 7th graders, we're going to go through lesson 4.4 and work on simplifying fractions. And this will be review for you, hopefully. We did this the last couple of years. Let's review, first of all, what fractions can mean. Okay? A fraction can mean the number out of the total, the amount out of the whole. It can be a ratio which compares two different amounts. Like in 7th grade, there are 10 boys compared to 8 girls. That's called a ratio. Okay? So this doesn't mean that there are 8 total people and 10 of them are boys. This compares two different amounts. That can be written as a fraction as well. But more commonly, we're going to be talking about fractions, which is the amount out of the total. Like the amount of points that you get out of the number available on an assignment, or on a test. Now, equivalent means that you have the same total amount, but the pieces are different size. So for example, when you look at this top row, 3 of the 4 are shaded in. Guys, you're distracting other people, okay? Brett is. So get on task. The first row, 3 out of 4 people, or 3 out of the 4 squares are shaded in. So that fraction is 3/4. And then if you cut them all in half, you have the same amount. Guys, get on task. Where are your notes? You're not on task. They're not out in front of you. You're not highlighting anything. You're not following along. We're not on this page. We're on this page. Okay. So, when we cut them all in half, we have the same amount shaded, but the pieces are a different size. So instead of 3/4, we have 6/8. Okay? That's what equivalent means in fractions. Equivalent means the same amount but different size pieces. So for example, you can find equivalent fractions by multiplying both numbers by the same number. If we multiply these by 3, then we would get an equivalent fraction. Okay? What is this, Lindsay? 12, 15ths, yep. And it's equal amount to 3/4, but these are different size pieces, okay? How would you find an equivalent fraction in lowest terms with this one? How would you find an equivalent fraction of this in lowest terms, Alex?
You just divide each one by 2.
By
and then
2?
Just keep dividing it by 2 until you can't divide it anymore. So then it would be 8 and 10, and 4 and 5, and 5 is prime, so you can't divide it anymore.
So you can factor out the common factors.
Yeah.
And start, if you want to start with 2's, that's fine, you can factor out a 2. But then you'll notice that there's still a common factor of 2. So you can factor that out again.
It should be 4 and 5.
Until you get to numbers like this. What can you tell me about these numbers? Tyler? 4 and 5, yeah. 5 is prime, yep. And so once you get down to a prime number, then what? Is it automatically lowest terms if you have a prime number? Well,
So
11 is a prime number here, but
5 and 10.
yeah, 11 goes into 22, so you can't just get down to a prime number. Stop talking, guys. What's the matter?
Do it every single time.
Okay, let's move on. 11 is a prime number, but it goes into 22. So if you have a prime number that goes into the other number, then you have to keep dividing it out. This is 1/2. Okay? You're looking for numbers that don't have any common factors. Is this lowest term 16/25?
No.
It's not? Why not?
Yeah.
It is.
The 6 and 2 to 16 is nothing.
Right. Yep. The other thing you're looking for in lowest terms, it says when either the numerator or denominator is a prime number, they don't go into each other. So in this example, or why are these lowest terms? They don't have any common factors. So write this example down. No common factors. There's no ingredients that you can take out of both. Remember, factors are like ingredients that make the number. They're like elements. 16/25, they're both composite numbers, but they don't have any common factors that you can take out of both numbers. Okay? Now, you're going to be doing some reducing of fractions that have variables in them. So, when they have the same variable on the top line and the bottom line, it's kind of like having the same number on the top line and the bottom line. Imagine that x is 5. So this is 2 times 5, which is 10. And this is 3 times 5, which is 15. How would you reduce that? Roy? If the x's were 5s, could you cancel them out? Or could you take those out?
Yeah.
Yeah. The 5 over 5 would cross out, and you'd be left with 2/3. 10/15 is the same as 2/3 by taking the 5s out. So if instead of numbers here, we have variables, you can cross off those variables and reduce it that way. Okay? Neat.
I just found a key on my desk and I already have my key. So, and I have like, yeah.
Just ignore it. It's probably not yours. It's probably not your warning. Jen?
Well, if they're two different variables.
If they're two different variables, then it's kind of like having two numbers that are not the same. Like 2/3. Only if they're the same variable can you cross them out. So if you have h over a, you can't cross that out. Because it's like having two different numbers.
How would you solve it?
You can't. That's simplified. That's simplest form then. Okay? Just like 2/3 is simplest form. Daria.
So if it's, let's say, like 3 or yeah, I don't know, like 3 and then 9, and they each have an x after it.
Yeah.
Then you can just simplify it, and the x's just go away.
Yeah, they are equal to 1.
The x's are.
The x over x. Look, it's like having the same number divided by itself. 4 over 4.
So
4 divided by 4 is 1.
So the answer
X
would be,
divided by x is 1.
so the answer would be 1 and 1/3.
Well, not 1 and 1/3. Because you'd have a 1 here and a 1 here. This is 3 times 1 and 9 times 1. It's basically 1/3. So it'd just be 1/3.
Because 9 divided by 3.
I'll show you some examples, and I think you'll get it, okay? Let's go to our assignment.
Yeah, what's 9 divided by 3?
So, to start with, the top part is just numbers. 8 20-seconds. What can you factor out of 8 20-seconds?
4 and 11s.
Yeah, you can factor out the 2's, right?
Yeah.
So it's 4 11ths. What can you factor out of 9 21sts? Abby?
3
What number can you divide them both by? 3. So 3 seconds. This one, I want you to write this one out this way, okay? On the top line you have 30, and use this line as the fraction bar. So 30 a squared is equal to 30 times a times a. And 36 a times b. This is called expanded form, because the factors are separated. Okay? And what you can see when you have expanded form is that these a's, a divided by a is 1. So we can write 1 there, 1 over 1, which is 1. And then we can reduce the 30 over 36 to
15.
factor up the 5s. 30 divided by 5 is 6. Oh, I'm sorry, not the 5s,
Yeah,
the
it's gonna
6s.
I was like,
Wait,
wait,
makes sense.
Factor out the 6s.
5 and 6.
So 30, 36 is 5 6. And what variable is left over? There's an a on the top line and a b on the bottom line.
Trigger.
So it's 5 over 6, 5a over 6b. Okay? Do the same thing for number 6. Write it in expanded form. 4x times y, and 14 x times y times y. Then, anywhere where you have a variable on the top line and the bottom line, so you've got x over x and y over y,
Oh, what?
and then those cross out, they equal 1 over 1. Each one of them is 1 over 1. 1 and 1, 1 and 1.
2 over 6.
Then reduce 4 and 14 to 2
7.
7ths and
And x.
x, y.
No, it's not hard at all.
Okay? Now, I want you to do 7, 8, 9, and 10. Actually, this equals, this is where you can write the answers. So you can write 5a over 6b right here, and 2x and 7y here. Use this line for expanded form, and then write those in simplified form. Okay? Then, do this column as well. So you got about 5 minutes here. Let's do these. Yeah. Any questions?
On the front side, on the other side where we were just on, I have a question on one of the problems for, number 7, so it would be 18 s times s times s times t times t, and then on the bottom would be 8s times t times t. Since there would be,
Since they don't line up.
it would, yeah, there's only one that lined up, it would be s and s.
Yeah.
How would we do that? Would it be then you
Diagonal.
Yeah.
TT and SSTT as
Yeah.
the-
Well, but he said.
Yeah, it really doesn't matter if they line up vertically, as long as there's one on the top and one on the bottom.
So then it would be, so divided by 2 would be 9 and
So
9,
these
4.
are gone, and then one of the set of S's are gone.
So then it'd be
9
9 over 4 with SS.
Take
No,
out
no,
S
it'll
to
be
the
not
second
S,
power.
yeah, S to the second power.
S to the second
S
power.
And then nothing on the
Or
bottom.
said
then-
that.
9 over 4,
Stupider.
because you take out the 2's.
And then
Here, that's
S squared.
okay.
Okay?
Yeah.
Alright. Make sure you model for